Is it better now?
Yes, sir, it's better. Yes, I'm reading it now.
Yeah, you said you are starting from question number what?
13.
13, okay.
Now, what is the percentage by mass of hydrogen in ethanoic in CH3COOH?
Okay.
So since they are looking for the hydrogen, and hydrogen has only one atomic number, I times it by 4
Okay.
over 60. That is the total one times 100. Since it's percentage. Percentage.
Okay.
Where I got my answer. So did you hear that?
Yeah. That's question number what? 13, ba?
Yeah.
I even thought we'll pass 13. Are you sure we've not passed 13?
No, we haven't. But I remember we've not gone into this atomic structure.
Okay. Okay. What is this?
Let's go to the
mass
next
of
number.
Yeah, that's 14.
So I think 2018 or 2019.
2018.
Oh.
Have you passed 13 already in 2018?
Yes, yes.
Isn't it?
We're number 8. Yes, we're number 17.
17, ba?
2018.
Okay.
Yeah. Okay, we've even done 17.
We've done what?
Or did we? This is where we were.
This is where we are.
Yeah.
What is on my screen is where we are, ba?
Yes, sir.
So I'm going to listen to your explanation. You say when a substance X is added to a solution of bromine water, the solution becomes colorless. X is likely to be what?
I think B. So I think B.
What? D?
17 C.
C?
C, sorry.
Yeah. So what? Why?
Yeah. Because they said that bromine is added to a solution. So I started searching. If bromine is added to an alkane, it doesn't give you a colorless liquid. If it's added to propanoic acid, it doesn't give you a colorless liquid. But once it's added to an alkyne, that is propane, that it gives you a colorless liquid.
Okay. So X there is propane, ba?
Should I go to the next number?
Yeah, you can go to the next.
Number 18.
Okay.
The preferential discharge of ions during electrolysis is influenced by the electrolytic reaction.
Yeah.
I don't really know the reason for that, but it's because of I'm familiar with that answer. That's why I chose it.
I didn't get you very well. Come again.
Like, I don't really know why it is prefer electrolytic reactions. It's just because I've seen it in my book before. That's why I chose it.
Okay. Okay, so before we get to that, yeah, so we'll go to that next. But before we go to that, when X is added to a solution of bromine, why is it that it turned colorless? Because X is propine, and propine is an alkyne, and alkyne can dechlorize bromine water because of its multiple
bonds.
Okay. Okay, so let's look at question number 18. Let me see the question. Okay, it says the preferential discharge of ions during electrolysis is influenced by A, mechanism of electrolysis, B, electrolysis reaction, C, nature of electrode, D, type of electrolytic cell. So which option did you pick?
I chose B, electrolysis reaction.
Okay.
B.
Okay, so factors that affect the preferential discharge of electrodes. That's the first thing. This is a topic under electrolysis. So there are several factors that affect how ion is discharged at a particular, whether it's at the cathode or the anode, during electrolysis reaction. Is that clear?
Yes, sir. Yes, sir. Rubbish. I can hear you.
The number one is the concentration of the ion.
Okay.
Mechanism of electrolysis, electronic reaction, nature of electrodes, and type of electrolytic cell. So the factors that actually affect discharge of ions during electrolysis are concentration of the ions in the electrolyte, the position of the ion in the electrochemical series. It's also a very important factor. Then we'll talk about the nature of the electrodes. It's one of the factors too. So you can even see that from that, option C is already the answer, not B. So the question says the preferential discharge of ions during electrolysis. So if you open your textbook, chemistry textbook, you're going to see factors that affect discharge of ions during electrolysis. So these are the three factors: concentration of the ion in the electrolyte, position of the ion in the electrochemical series, and nature of the electrode. Those are the three factors. And in the options given, the number, the C, the number third factor is the C. And that is why C is the answer. I don't know whether you understood
this. Yes, I understand. I now remember.
You said?
I said I understand. I remember now.
Okay. So these are under factors that affect electrolysis. Factors that affect the preferential discharge of ion during electrolysis. One is concentration of the ion, that particular ion in the electrolyte. Number two is position of the ion in the electrochemical series. And number three is the nature of the electrode that is being used.
Yes, sir.
Yeah, so let's move on. Can you read out the next question? Ali, have you scanned all of it? Have you sent to my email?
Yes. All of the subjects.
The files, you put them back inside.
Have I sent what?
Yes,
You said?
So you said if I've sent what?
No, it's not you that I'm asking. I'm asking somebody that is there. Just continue with question number 9.
Number 19, the valence electrons of magnesium are in the R3s orbital, 2p orbital, 2 orbital, and 1s orbital.
Okay. So what do you
and
think?
the answer is A, because when you find the electronic configuration of magnesium, it will be 1s2, 2s2, 2p6, and 3s2. So it will end with 3s2.
Okay. So that is the balance, isn't it?
Yes, sir.
You know, when we learn balance, it says the one in the outermost, isn't it?
Yes.
And this is the electronic orbital configuration. First of all, you need to note that you need to note the what's it called? The number occupied by magnesium, which is 12. You understand? So you must make sure that you exhaust the 12. So here we have 2. 2 plus 2 is what?
4.
Plus 6.
That is 10.
Plus
another
2.
12.
Good. So you must exhaust
That is 12.
Yeah, you must go from 1s, 2s, 2p, 3s, and upwards. So let's move on to the next one.
Should I read the next question?
Please do.
The stainless steel is an alloy comprising of A, iron and copper, B, iron and nickel, C, iron, nickel, and copper, D, iron, copper, and aluminium.
Okay.
I chose C.
Chose what?
And chromium.
Okay.
Is it chromium or carbon?
Yeah, it has chromium for a very small amount of copper, of carbon.
No, like the C, is it standing for chromium? I thought it was CR that was standing for chromium, not C stands for carbon.
Yeah, it's actually supposed to have also chromium or small amount of carbon, but this very C is actually standing for carbon, the one in the option that you have.
Yeah.
Once the letter C, just C in chemistry stands for carbon.
Okay, sir.
Exactly.
Yes.
Okay, so let's move on to the next one.
Clear. I read the next question. Hello, sir.
Yeah, can hear you.
Should I read the next question?
Yeah, please.
You said the number of hydrogen ions in 1 mole per gm cube of 0.02 mole per gm cube. Temperature of the sulfuric acid is 6.0 times 10 raised to the power 23 number of atoms.
No. It's not saying that the number is this. This is just a given parameter. This is just given. The Avogadro's number is given as 6.
The Avogadro's constant.
Yeah. But you are expected to calculate the number of hydrogen ions in 1 dm cube.
Yes, sir.
Of 0. This tetrahedral. Yeah. Okay.
So I did 1.0 mole per dm cube is equal to the Avogadro's constant.
Yeah.
Since they're asking for the number of hydrogen ions, and I said 0.02 is equal to x because we don't know what the number of hydrogen ions is. So when you cross multiply, you get your answer.
Okay.
So that is all I did.
Okay. So that makes option what the answer?
That makes option A the answer.
A the answer. Okay. So let's move on.
Mommy.
Are you there?
Yes, I'm here.
Yeah.
Please, I'm coming. Having some network problems. I'm coming.
Okay.
I can hear you now.
Okay. So let's do number 22.
The most suitable substance for putting out petrol fire is A. Water, B. Carbon dioxide, C. Fire blanket, D. Sand. I chose B.
Okay.
Because
So
CO2 is known as an extinguisher.
Okay.
It's used as an extinguisher.
Okay. So CO2 is a very important fire extinguisher, and it's very, very important because it is denser than air. So it can actually cut off oxygen supply to the burning material. Thereby, without oxygen, once oxygen is not supplied to a burning material, it cannot burn anymore because oxygen is needed for burning to occur. So CO2 is able to cut off the supply of oxygen to that fuel or the petrol that is causing the fire. So it's one of the uses of CO2 under carbon and its compound. So let us move forward, Abby.
Yes, sir.
Okay.
Number 23.
Okay.
The following factors would contribute to environmental pollution except A. Production of ammonia. B. Manufacture of cement. C. Photosynthesis. D. Combustion.
So which is
I
the answer?
chose C.
Huh?
C.
That's photosynthesis, isn't it?
Yes.
Yeah,
Because
photosynthesis
cannot
cause
contribute to environmental
yeah,
pollution.
yeah, it's simply used for, that's how plants get their food, the autotrophs. That's how they get their food. So it cannot be causing harm to the environment.
Okay, sir.
Abby? That one is pretty clear,
Yes,
isn't it?
sir. Yes.
Okay.
Then number 24.
Okay.
The position of equilibrium in a reversible reaction is affected by number 12. I chose by the presence of catalyst because catalyst helps in the speed of the reaction, helps to speed up a reaction.
Okay. So, but is that the only factor that, do you know about the factors that affect equilibrium?
Yes, concentration, pressure, and
Okay. Concentration of the reactant, isn't it?
yes.
Or products, pressure, isn't it?
Okay, so the factors that affect rate of reaction is different from factors affecting equilibrium position.
I can't hear you very well. Just speak up.
Is that the factors that affect equilibrium position is different from factors that affect rate of reaction.
Yeah.
Okay.
Okay. But what was the question on? The question says the position of equilibrium in a reversible reaction is affected by what? Is it by the particle size, vigorous stirring? All those ones actually affect the rate and not equilibrium, isn't it?
Okay.
So
Yes.
different factors affect the equilibrium position, whereas different factors affect the rate of reaction. So rate of reaction, how fast the reaction is taking place, is affected by things like particle size, how vigorously you stir the reaction mixture, and the rest. But when you talk about equilibrium position, it is actually affected by the concentration of the reactants or products, pressure of the reactants or product, temperature. In that case, if the reaction is an endothermic or exothermic reaction. So those are the three factors that actually affect the equilibrium position. So from those three listed, which one do you think now is the option? You said it was C before, huh? Or D?
Yes, I mixed it up.
Okay. So from what is just listed now, what do you think is the answer now?
Concentration of the reaction.
Good. Change in concentration of the reactant, because that's what affects the equilibrium position. Pressure of the reactant. You just know that concentration, pressure, and temperature are the things that affect the equilibrium position. And when you're talking about temperature, you're talking about whether the reaction is endothermic or exothermic. But when you're looking at factors that affect the rate of reaction, it's different. In that case, B would have been an option. Particle size, A would have been an option. Catalyst would also be been an option. So you can see that these three options here are for rate of reaction and not actually for equilibrium. The only one for equilibrium is option D, and that makes D the right answer to B.
Yes, sir.
Is it clear?
Yes, sir.
So I can now ask you, what are the factors that affect equilibrium position? You know the three now, B?
Yes, I know.
I also know the factors that affect the rate of reaction, isn't it?
Yes, sir.
Okay. So let's move to the next.
Now this one, there was confusion.
Okay, there was confusion in it.
Yes, because past question, the answer was saying a different thing. Internet was saying a different thing too.
Okay. Okay.
I felt that it's B.
Huh?
I said I felt that the answer was B, but internet was saying C, and the past question she was saying C.
Okay, in the past question they
Did
said
I
A.
explain my point?
Yeah, please.
No, they said C, that when energy is released, it changes ice to water. But it's when energy is absorbed that's when it has that energy to change from ice to water.
Okay. Let's listen to what the explanation I gave you first. So temperature E, energy is released when the ice changes to water. D, the water molecules vibrate about a fixed point. So, which is the answer to this? From what is read now, B is actually the answer because energy is absorbed when the ice changes to water. Ice is a solid form. You need energy to make it to be liquid form. So that makes that the answer. Now, how do we eliminate the other answers? Now you have that the water molecules vibrate about a fixed point. This is not true. Why is it not true? Because this is what happens for solid. But water is liquid. So we cannot say that the molecules vibrate about a fixed point. This is what happens for solid. So that makes this answer not to be true. Now, the first one is that the water is at lower temperature than the ice. It can never be true because you know that ice has very low temperature. Like when you go to tropics, like in Russia and other places where you have snow falling, temperature is very cool because of ice. Not like that you have water. So the temperature of ice cannot be higher than that of water. So that of water cannot be lower than that of ice. That makes this correct. And when you look at the energy is released when the ice changes to water, that is wrong because you actually need energy for you to change the solid to liquid. You understand? So this is also that makes me that energy is absorbed immediately. Once you add, if you want to also learn about it, just put ice block inside something, then apply heat, apply energy in form of heat. So once you apply energy, you find out that this ice block, this very ice block, will change to water. So you need heat to do that. So energy is absorbed. So this system will absorb energy. This system will absorb energy. Energy is absorbed to change this ice to water. So that makes option C correct. Very clear. So this is actually an endotermic process because there is reception of energy. So it's actually an endotermic. So there is reception of energy. Thank you. Did it make sense? So that
yes,
makes that
but why is it that is when the answer, not when the energy is released, ice changes to water. Because as it's ice, it's solid, there's still energy. So when it now changes to water, the energy releases. Why is that not the answer?
Okay, you ask, so why is it not that when energy is released, that the ice changes to
Yes.
water?
Yes.
But in order to make ice change to water, what do you think? How, like, what do you think that will make ice to change from ice to water?
By melting.
Melting, bro. So what
Yes.
is the easiest way to melt something? When you apply heat, will it melt? It's easier to melt, isn't it?
Yes.
So heat is a form of energy. You understand? So when you're applying
Heat is,
heat to the ice,
yes.
when you're applying heat to the ice is absorbing the heat. You understand?
Yes, sir.
And when it absorbs that heat, the particles of that ice, they will gain kinetic energy and they start moving and turn into water.
Okay, sir.
Do you understand?
Yes.
Do you understand?
Yes. So
Okay.
it needs that energy to change
Good.
from ice to water. So
Good.
that's why the energy is absorbed.
Yes.
Okay.
Yeah. You can call it
Understand now.
latent heat.
Heat.
It needs that heat, that energy in order to change from one state to the other.
Yeah. Latent heat of fish.
Okay.
So I'm going to the next one. 26. Which of the following statements about best explains differences between a gas and a vapor? Sir, can you hear me?
Yeah, I'm hearing you.
I choose B because unlike gases, yes, because vapor can be condensed to liquid into liquid,
Yeah.
and gases cannot be condensed into liquid.
Which of the following statement best explains the difference between gas and a vapor? Unlike gases, vapor are liquids at room temperature. That cannot be the answer. Because vapors are not actually liquids at room temperature. Then option C, unlike gases, vapor is readily converted into solid. No, vapor are generally denser than gases. So unlike gases, vapor can easily be condensed into liquids. Yeah. So that's the right answer.
Yes, sir.
Unlike gases, vapor can easily be condensed into liquids. Yeah. Because the formation of vapor is actually done as saturation. So there can be easy movement between the solid and liquid state at that equilibrium environment. So B is actually the answer. You're right.
So should I go to number 27?
Yeah, please do.
Number two. Said consider the following reactions.
Yeah.
2HCl plus calcium CaOH2 will give calcium chloride plus water. What is the volume of 0.1 mole per dm cube? What is the mole of 0.1 mole per dm cube HCl that will completely neutralize 25 volume of 0.3 mole per dm cube?
Okay. So continue. Are you there? Ah.
I said that I understood the formula, but I don't know when to be using this formula now. Is it when there are volumes and reactions?
Yeah. Okay, you understood the formula, but you don't know when to use it.
Yes.
Okay.
Because there are so many formulas in this titration.
Yeah, that's true.
I don't know.
Okay. The thing is that this is the typical neutralization reaction. You understand? This is a typical neutralization reaction for what's it called? For titration. If you're having titration, if you look at the what's it called? If you look at the reaction, this is HCl. HCl is hydrogen chloride, which is a gas, which is an acid. Then we have calcium hydroxide, which is a base. And whenever an acid reacts like with a base in this form, we have
it's
salt.
Called neutralization.
Yeah, it's called neutralization, salt and water. So the most important thing is for you to look at the parameters that are given here. You are given the what is the volume of 0.3 mole per dm cube HCl. So you are asked for volume and you are given concentration that will completely neutralize this volume of this concentration. So you can see that you have two concentrations, both for the acid and for the base, and you're given one volume, which is the volume of the base, and you're asked for another volume. So that means you're given two concentration of acid, concentration of base, and volume of base, but you are now expected to find the volume of the acid. So in that case, when looking at what you are given, that's what will inform the formula that you're going to be using. So in this case, you use this is a typical titration formula. Concentration of the acid times its volume all over concentration of the base times its volume is equal to the number of moles. And this number of moles you can easily get by looking at the reaction given. What is the coefficient of the acid? 2. And that's why Na is 2. And what is the coefficient of the base? Is 1. Whenever nothing is written, that means it's 1. That's how you got this 1. So these other CAVA, CBCB, CBVB, you can get from the parameters given. Ca, which is the concentration of the acid, is 0.1 mole per dm cube. Cb, which is concentration of the base, is given here, 0.3 mole per dm cube. The volume of the base, Vb, is 25 cm. Na is the number of moles of the acid, 2, whereas that of the base is 1. So when you fix that in this, you make Va the subject of the formula, you get 150, and that makes option A the right answer.
Okay, so
is it okay? Okay,
yeah.
so if you want to look at when to pick out this formula and use, once you hear the word neutralize, and you have volumes given and concentrations, mole per dm cubes given, then it's most likely that you're going to be using this very formula to sort it.
Okay, sir.
Okay.
Yes, sir.
So let's look at the next one.
Number 28. C and HNO3 are not suitable for preparing hydrogen gas because of their. Number 28, I just saw the answer immediately. Cu is because of the copper is good for conductivity. And
Copper is what? He said,
sorry, I don't even know what I'm saying again.
and I
I
try it.
don't know what I'm saying.
Mhm.
I thought copper could conduct electricity
Okay.
because of the metal. And HNO3, that is making HNO3 to be corrosive. That was what I thought.
Yeah.
But it looks like I'm wrong.
Yeah. Yeah, you're wrong. You have an idea, but it's not looking at the question. The question given. If you look at the question given, it says, "Why is it that you cannot use the both of them to prepare uh, hydrogen gas?" So that's the question. Copper
Yes, ma'am.
and HNO3 are not suitable for preparing hydrogen gas because of their what? Reactivity and oxidation, respectively.
So, sir, HNO3 is for oxidation.
Yeah. See?
Okay,
You know
and
HNO3
I said
is an oxidizing agent.
HNO3.
It's an oxidizing agent.
Okay, sir.
Yeah.
I tend to be an reducing agent since it goes through oxidation.
No. It's an oxidizing agent. It's gonna be uh, most acids, concentrated acids are all oxidizing agents. You have to take note of that.
Okay,
That acids are oxidizing agents. Concentrated acids mostly they are oxidizing agents. Also, halogens are also oxidizing agents, whereas metals are mostly reducing agents.
okay, sir. Thank you.
So, see, my lights just went off. So I'm gonna on gen, then I will log back in. Okay.
Okay, so
I
by
want
what
us to
time today?
I want us to try and finish this one today. If we don't finish it, then it will take us time. I want us to finish it so that at least next time we'll enter 2019, isn't it?
We can go to another year.
Yeah. That's my target.
Okay, sir.
Oh, I'll just get home. I'm still in my office and the light just NEPA took light. So I'll get home, then I'll on gen, then I'll log back in. So give me like 20 minutes. 20 minutes is okay. You will not sleep by then, huh?
Okay. No, sir.
Okay. So let me log out now. Thank you. See you when I see you.
Okay, sir. Thank you.
Yeah.